Hey everybody, welcome back to HPC Tech Shorts, the engineering water cooler here in AWS. This week we've got a couple of interesting shows talking about the Winter Classic Invitational Student Cluster Competition. Now, if you've never been involved in a student cluster HPC competition, today is going to give you a really good insight into that entire universe. AWS was really excited to be able to be one of the mentoring groups to help with the student cluster competition this year. These are good things to support if you're able to support. So I'm going to encourage everybody else that's out there to get involved as well. Let's see. Here we are. I've got a whole collection of people here. Couple of familiar faces. We've got Ollie Perks from the AWS DA team. Hey, Ollie.
Hey, Epi.
And Evan Bollig in Minneapolis. Hey, Evan.
Hey, guys.
Evan's the backbone of our specialist SA team in public sector in North America. And Dan Olds, the Chief Research Officer from Intersect 360. Hey, Dan.
Hey, how are you guys?
Now, Dan, what do you have? How did you end up messed up in all of this?
I started out with student cluster competitions back in 2010. And wow. I decided to become the informal historian of all student cluster competitions with the express desire to turn them into college football for nerds. And so I started documenting them in my interviewing teams and looking at the results and making it into a horse race. Back in 2010, publishing a lot of stories in the Register and in HPC Wire, the typical places. And then last year, well, 2019, I had the thought, with this virus and everything, there's room for another competition, for a virtual competition, and decided to do what I call the Winter Classic Invitational Student Cluster Competition, because to me it sounds cool. Sounds like a really high-end golf tournament. And I decided to go after not the regular schools that have lots and lots of HPC stuff, but to go after schools that really don't have a shot at this because they don't have resources. Right. And so we're going after exclusively historically Black colleges and universities and Hispanic serving institutions. So that was year one. I was a one-man band. And when I joined Intersect 360 a little over a year ago, Addison embraced it, and we really went off to the races this year, and we've sort of changed the entire architecture of how these things are done.
Well, it's super important. We get in, I've been involved in a whole lot of the women in HPC efforts around supercomputing and IC over the last few years. We have to do something so that to mix things up so that it isn't for white middle-aged dudes. Mm-hmm. Sorry, for very young white dudes talking to each other on one of these programs, right? It's super important because the HPC community is incredibly important to humanity.
Yes. But there's a big desire out there in the schools that I've been working with to get in to this. Right. They don't have a natural on-ramp. It's not like they're, the Ohio State University or Purdue or somebody that has a supercomputer and has professors that have contacts that can get them in. So this is an on-ramp for them. The typical competition has students working with their faculty and maybe their vendor to learn things 3 months, 6 months ahead. But in our situation, these kids don't have on-campus clusters. They don't have access to the systems. Their faculty, while they've had some experience in HPC, they can't carve out a whole lot of time to do this. I mean, the big schools have an entire class just for the competition. These schools can't do that. So what we want to do in thinking about this, how can we get the community to do this, to help out with this, and the community to really get involved and passionate about it? And that turned up the idea that instead of having the students learn this on their own with their faculties, let's have a week with one mentor organization where every team gets the same instruction. Every team then can use the same clusters, level playing field. And that worked just beautifully.
Right. And it's leveraging the fact that everything's still virtual at the moment. So no one's having to pay for flights to all be in a conference hall in the middle of the US, or
let me say
across.
Let me say that COVID was a great democratizer. It was a huge leveling function for all of this stuff. Ollie, if you think back to the hackathon that we ran in the middle of last summer,
right? Geography just didn't matter anymore.
Geography didn't matter. Travel budgets didn't matter. And I got to say, the guy who came third, he was a team of one, and he came third in the competition. He kicked butt, and he did it all on his own from I think by just never sleeping for a week. But,
that's a great story. He wanted it.
Was amazing. He was really cool, and he came from a background where he did not have access to all of the resources that you might imagine somebody to have. So
fantastic.
So that's what we love to see in these things. So we've got to make sure that we get some of the get the student groups up on the screen, because these are the heroes of the moment, right?
This is why we're doing it all. We had some great teams, a good mix of teams that had done it before last year with my competition, and then new teams. Like we had 2 teams from a school I didn't know existed, but it turns out that it does. It's California, Channel Islands State University from California. And they're about a 6,000 student school. They could have almost had 3 teams. Their students were so excited by this. Cal State Fullerton is new. Fayetteville did it last year. Florida Agricultural did it last year. We had 2 teams from Morehouse, where we had 1 team last year. One from a combined team of Spelman and Morehouse. We have Prairie View, who was the very first team ever to sign up for one of these competitions, one of our Winter Classic competitions. And they won it this year. And we're going to talk about how in highly dramatic fashion. Tennessee State University is returning team. Texas Tech, 2 teams. And it was great for the universities that had 2 teams, because I tried to stir the pot.
And somehow I can't imagine you stirring the pot, Dan. I mean,
I know. I couldn't help myself. We're
such a shrinking violet.
Doing a lot of team interviews. We even, with the support of our sponsors, sent them out for meal nights and then dipped into their conversations and filmed them there. Another great team, by the way, University of Texas, El Paso. Don't mean to leave them off. They did great this year.
I was going to say that the teams weren't on their own. And this is something that we've mentioned briefly a few times. So talk us through the support that they're being given all the way through this.
Well, let me just take for an example. We'll talk about the AWS part of this, but I want to use HPE as an example, as a mentor organization. We had 4 major mentors: AWS, Oak Ridge, HPE, and NASA. Also, BioTeam acted, and I have to remember to get them in. They acted as our SEAL Team 6. If teams got into trouble, they would parachute in the persona of Shane Corder, who is scary good at HPC, and pull that team out of the ditch by dint of will alone. And he did that with a couple of teams. It was very helpful. But the way the mentorship worked, that for instance, with HPE, they sponsored or they mentored LinPack and HPCG. And on Monday of the competition week, they presented about, I want to say 3 or 4 hours of material that was in some cases pre-recorded, some cases live, but it gave the students kind of a grounding in HPC concepts, MPI, things like that. It taught them how to log into and use the HPE clusters that they made available to the students. And then they talked about how to run the application. And then they were on Slack for Monday through Saturday, had people manning Slack at all sorts of hours. just to handle the questions and to make sure the students had every chance of success. On Saturday, that's when they did their final run. Their speak now and or forever hold your peace, don't leave anything in the locker room, complete full out runs, and they turned in their scores.
Now what were the other mentors? So NASA had the Naspar benchmarks.
Yeah, they did a subset of Naspar. We're not going to go through the play-by-play yet, but it was really interesting how the teams did on that.
So each of those benchmarks represents a very different application characteristic. So they all are micro benchmarks of algorithmic routines. So
right, but when you're talking about high performance computing, those are the complex kernels. That's where the bulk of the work is spent. And so if you tune that performance, you tune the overall performance of your code.
We also had in between there, though, we had an HPC Pop Quiz because we had a scheduling snafu, and I figured I could give them another week off, or I could torture them. I kind of went the route of the torture, coming up with 20 multiple choice questions.
So let's see. The next workload was machine learning. It was with the Ornell folks.
Oh yeah, they threw a curve. They threw a big curveball to the students with machine learning. They were working on the Ascend cluster, which is a smaller version of Summit. So it was also their first exposure to GPUs. And it wasn't traditional cluster, benchmarking. What they did is they ran some code and then they answered a lot of questions about what's the minimum size model you need for this, what's the maximum, a whole bunch of questions that confused me. So I can't go into depth on that very well, but it stretched them. It stretched them out, but they picked it up, which I thought was really cool.
So, guys, when I was in grad school, I was going through principal component analysis and other topics that they went through with Oak Ridge in this block. And I was shocked that these are young kids in many cases, and they picked it up, they understood it, and they excelled on it.
Then we came to you folks, the AWS Open Foam Challenge. And I don't know, have you had Neil Ashton on your show before?
Oh, yeah.
We did an after interview after the results were released that if anybody wants to check it out, it's on our YouTube.
And I will hang on, I'm gonna flash this up here, just so everybody know that it's real, and the Yellow Jackets.
Yes. And yes, I do want to mention that the Yellow Jackets were key to the success of the Winter Classic Studio Update show. For the Americans out there, this is a big throwback to Monday Night Football and ABC Wide World of Sports.
Did they cost you $6 or $7? Those jackets.
You would be amazed how much those cost us.
Right. I didn't think the polyester rayon was that expensive, but nonetheless.
When you make it this thick and this durable, oh yeah. Yeah, you could tow a car with one of the sleeves of these things. Machine washable, the only thing kryptonite is fire, I believe.
Right.
Any sort of open flame or spark, and you're probably a dead man wearing that thing. But the AWS challenge turned out to be a huge turning point in this competition. It was key. And the way it was structured, and I believe Neil probably put this together.
Yeah.
He left a back door.
I hope many of the viewers here are familiar with Open Foam.
See, I can use this as an opportunity to plug my friend Chris's book, because he just wrote. He's one of the people who founded Open Foam, and he's just wrote the book on it. He and Henry. So
excellent
product placement.
And again, for all your CFD needs, make it Open Foam.
Right. It comes in a range of colors to match your bathroom decor as well. Absolutely. Anyway, Ollie, tell us about the workload.
Right. So again, anyone familiar with Open Foam will know the motorbike example. It's one of the pretty standard tutorial examples. But again, we're modeling a motorbike with rider and the airflow going over, maintaining a validation on that simulation, in this case, based on the coefficient of drag produced by this. And this is great because we can generate visualizations based on it and really give the students an idea of what it is they're running and real world implications when things go wrong or go right. Right. So the whole objective of this was carte blanche, make it as fast as you can. Right.
But on Intel and AMD clusters.
Exactly.
And run it 500 times.
It was a real world example, right?
Yeah.
So
you're given a challenge to turn around the science faster.
Okay, so their objective was to make it as fast as possible.
Yes.
And there was a backdoor left in there, which we are gonna, and this is where we are gonna, I'm forewarning everybody, we are gonna leave you on tenterhooks. There is going to be a cliffhanger at the end of this show because we're going to get you to come back to the next show to find out who shot JR in the next episode. Coming into this last round, I gather there was 30 points separating the top 6. There was quite a cluster.
But one team was out front by the top team was out front by about 50 points, a little over 50 points, and no one seemed to be able to reel them in.
Right. Until
the Open Foam Challenge from AWS.
Open Foam Challenge. Boom! I need some bonging sort of sound.
That would be great. Yeah, just insert that in post production. But then we came down to the interview, and the interview is what told the tale for everybody.
Right? Because let's reiterate. So we came into the end zone after the challenge. It was squeaky. We call that squeaky bum time here in the UK. It was squeaky bum time because there was very little gap between number 1 and number 2 team.
Out of 600 points that could have been earned for perfect scores throughout, there were 2.21 points separating first and second, and between third and sixth, it's like 33 points. Out of 600 with another 100 points to go.
Whoa. So with that, we'll come back and actually reveal how all that happened. We'll show you how this play-by-play rolled out, and then we'll tell you about how the winner won and what their sneaky trick was.